we'll talk about scope in this video. A scope in any programming, in our case, C and C++ programming is a region of the program where a defined variable or a data piece can have their existence. And beyond that region, variables will not be able to have any accessibility, or information cannot go through. This is the nature of scope, right? So we have two types of scope. One is what we call global, and the other one is what we call local. We'll give examples of each of these to illustrate what they are. This is an example, a code piece that illustrates various different scopes. There's a global scope. There's also local scope that you see inside this main, right? There's also another nested, right, block of area inside of main in yellow right here. This is also another scope. You also have a functional scope, a function where all of the variables sits within, right? So just look at these. You can see that when you're referring to a variable A, notice that there's also another variable A, even though these variable names are the same, they are of different scope, meaning this A right here inside this nested block is different than the A outside, right? So you can consider this A as local. Local to what? Local to this entire scope right here in the yellow regions. Now, this A here is local to this main area, right? Which means when you are looking at this variable A inside this main area, you don't really know the existence of this A because this A sits inside another scope, right? So this is one scope. This is another scope. There's also another scope here. And of course, this A right here is different than this A and also this A, because this A here has a functional scope. As you can see, the scope is really, when I say region, it's really like a wall, right? A demarcation that differentiates, allows the information, certain informations to be blocked. And these informations tend to be local, right, to within that region. Therefore, people outside of those regions would not have access to it. So that's really the essence of scope, right? We're able to separate informations from what they need to belong. And of course, this entire illustrations here is a bad example in real practice, right? You should never have, nested areas like this using the same variables over and over again. And plus, the naming convention is very, very blurred. We don't know what this A is, right? So this is actually poorly illustrated examples here, but nonetheless, this illustrates the scope for global, right, and local scopes. So this is saying that variables are in scope from declaration until the end of their blocks. So these blocks are typically encapsulated by a pair of curly braces here. So if you have a variable here, integer x, right? Now this x sits inside this scope right here. And the existence of this x, or the visibility to it, happens right from the beginning of this establishment, right, scope until the end of it. But as soon as you come out of this curly braces, meaning you're outside of the scope, you won't have visibility to this x anymore. As soon as you exit this scope, you won't have access to or visibility to this x anymore, because this x sits inside the scope. And what is outside the scope is considered to be the area outside of this ending curly, right, in program. This is a basic C program here. Let's run it. So this thing compiles. Let's talk about scope here. Let me introduce what's called a global variable. The reason why this is global is because this is outside. Let's say this global variable is Z, right? Let's just assign a value to it. Let's say this is 10. Right, so this is in global scope. This means that from this point on, right, this line 4, 5, 6, and on, everyone underneath, right, this line will be able to have access to this variable Z in a function that you have here called main, right? You can also have other functions as well. They all have visibility to it because Z sits outside, literally outside of all of the functions out there, including main. So this global variable could be seen, in fact, inside main, right? So if we do a printf, just going to do a generic print, printing out as a digit, right? And then with a new line and called Z here. If we compile this, we'll see that the value of 10 is printed. The reason is because inside this main, we have access, right, to the value of Z. And that is because Z is a global, right? Let's just say if, you know, for all intents and purposes, we're going to want to change, right, Z by doing a plus plus on it. So this will give Z the value of 11, right? So if we print Z then at the time, we'll see that this is 11. And that is because this Z, right, is sitting inside of main. It's a global variable, right? Now, let's just say for all intents and purposes, we set up another one. This is never a good practice, okay? But let's just say this is 0, right? This is Z. Now, do you think this Z is going to run into some sort of collision with Z? Well, in fact, not. What we're doing here is we introduce what's called another Z, and this is what we call a local variable, okay? This local variable has its own scope inside the main, right, function scope. This is a function scope. Now, remember, the scope is a region, right? It's almost like an invisible wall that blocks the access of the data from, you know, going in and out of this wall, right? So when you're inside this curly braces here, you have your what's known inside a function scope, and this Z sits inside of that invisible wall. So when you do a plus plus on it, actually, if you don't even need this, right? Do you think this is going to print 0 or 10? Would this Z be referring a global variable or a local variable? Let's do a test. Right, as you can see, right, this Z references this local variable, right? So therefore, it is very, very important to define, when you define variables, you got to know what is in a global scope, what is inside a local scope. Therefore, it is very, very important when you design your program, you should know what those global variables are, what those local variables are, right? And definitely don't want to mix and use these variables, especially their name, to create confusions like this, right? So this illustrates local variable, global variable, as well as functional, right? You can also have a local scope such as this, right? Remember, you can carve out your own invisible wall and say Z is 1, let's just say 99 here, right? If we do a print F inside of it right here, do you think this is going to print Z as 99, as 0, or Z as 10? Let's do a test run. Let's get rid of this too, right? Just to be clear, we only have one printf. As you can see here, this Z now refers to this 99, right? And it's because this Z is local, right, to the scope right here. So this is what we call a local scope, right? You don't want to use this a lot. In fact, you know, this entire illustration is never a good practice in real life. But this illustrates, right, the differences amongst these various different scope where variables are, right, with respect to each other.